Hi everyone, nice to have you on my channel today. In this video today we'll be looking at construction of helix, how to construct helix. First of all, let's try to define helix. A helix is the locus or path traced by a point on a revolving or rotating cylinder. A complete revolution of the cylinder is what we call the pitch. We call that the pitch. Helix form the construction of some important machine components such as screw threads, coil spring, twist drills, worm gears, propeller blades, cylinderical cam, square thread, and so on and so forth. Now we are going to be constructing a 2-ton helix in this video. There's a question we are going to be looking at now. Draw a 2-ton helix given the diameter of a cylinder to be 40 mm. Determine the pitch of the helix. Don't forget I said a complete revolution of the cylinder is what we call the pitch. So we are going to be drawing the helix now, then bringing out the pitch. So I will start off straight away. I will draw this line, horizontal line, that way, thin line. Okay, now let's have a perpendicular line drawn at any point to that line. Okay, perpendicular line. If I draw that at this point, okay, we have this that way, and we are told that the diameter of the cylinder is 40. The diameter of the cylinder is 40, so I will measure 20 for the radius. Okay, compass drawing radius doesn't draw in diameter, so this is 20 to this side, making 40 at this point of intersection where the vertical and the horizontal line coincide. So I will draw this. We have this. Okay, this circle drawn. So the next thing I'm going to be doing now, I will divide the circle into 12 parts. So with this same radius I use in drawing this circle, so I'll place at each of the points, 4 points we have on the circle. So strike an arc up and down this way, then we'll place here, strike an arc at both sides, then at this point strike an arc like this, then finally on this point strike this arc, then this arc. So let's number that point, that side. Let's start with 0 like this. So we say that is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 and 0 on the same point. So I will join point 11 to 5, passing through the center. Okay, 10 to 4, passing through the center, then 1 to 7, passing through the center, then 12 to 2 to 8, passing through the center. I hope we can see this very clearly. So the next thing I'm going to do, from the base of the cylinder or the circle, okay, I'm going to draw a line this way. Okay, then close to the figure, okay, at any convenient distance of choice, I'm going to be drawing a vertical this way, like we have here. Okay, you see, like we have here, this way. Okay, so let's call this point now. Let's call this point our 0. Okay, so now I'm going to pick the circumference of this circle. Okay, the circle is rolling. It's rolling like we defined helix as a locus. Okay, you know, locus is a rolling circle, okay, following what a curved path, okay, that is traced by a point on a revolving or rotating cylinder. So this is revolving, is rotating along this line. So I'll pick the one of the division, okay, because they are equal to each other, as you can see. So I'm going to spread it out here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now this is 12. Now let me number this first before I say what I want to say next. This is 4, 5, 6. We have this as 7, 8, 9, 10, 11, and 12. Now the question asks us to draw a two-tone. It's a two-tone helix. Okay, if it's a two-tone helix, so it's going to be having, that means it's going to be having two pitch. Okay, this is for a single tone because it's going to roll, okay, in a single form like this, but we are asked to draw two tone. Okay, from this 0 to 12 is 1 tone, so I have to continue this again, starting with 1 now until I get to 12 again. 2, 3, 4, 10, 11, and 12. So I have to extend this line in order to give us 12. Okay, so we have this now. So we have this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, we did this because we are drawing a two-tone helix, and don't forget it's going to have that means it's going to have two pitch. So the complete revolution of the cylinder is called the pitch. So as it's complete this revolution to this 12, that is 1 pitch. Okay, now I'm quickly going to draw this now. From each of these division now, I'm going to draw perpendicular. Quickly draw perpendicular up this way. Okay, place at each point that way. So I'll quickly draw perpendicular. So I'm going to draw like that across until I get to the final one. This way. Okay, so I'll draw this now. Extend this line to meet it that way. Okay, now we have this completely drawn out now. Now for each of these, for 7 and 5, 7 to 5, I'm going to draw, place at 7 to 5. I will draw across it this way. Then 8 to 4, once your t-square is squared, you don't need to bother whether the line is straight or not. Okay, 10 and 2. Okay, then 1 and 11. Then finally 0 and 12. We have that drawn, okay, this way. Now the next thing we are going to be doing now is to get our point for the helix. Now we start with this 0 and 12. So this is our 0, the first point here. Then 1 and 11. This is 1. Follow the line. This is 1. Trace 1 up. So this is our 1 here. Then trace until you get to 11. So this is for 11. Then do same for this side also. This is 1 and until we get to 11. Okay, then this is our 12. Okay, so you have that like that. Then we go again. So next one 2. This is 2. Trace it up. So this is 2 and 10. Don't forget 2 and 10. Okay, go this way until you get to 10. So this is 10. Okay, come here 2. Okay, this is line 2 where it coincides with this 2. Then 10. So this is 10. You can see. Then we'll go to the next one now. Next one now 3 and 9. So this is 3. You can see. Then 9. This is 9. Okay. Then come over here 3. Okay. Then you have 9 here. So you can see. Okay. So we go again now. So we go to 8 and 4. This is 4. Then just follow the line that way. This is 8. Then 4. This is 4. And this is 8, as you can see. The next one 7 and 5. Where's 5? This is 5. Then go to 7. So this is 7 here. Okay, this is 7 and 5. This is 5. Okay, then 7 here. So you can see here. So finally we have 6 here. This is 6. This is 6 here. Then next one, go check for 6. This is 6 here. Okay, so that's the final thing there. Now we are going to trace out this curve. Now you can see it will go this way. Okay, I didn't take note of this 12. This 12 here. This is the 12 here. This 12 for this. Okay, so it's going to go this way. This way. So we are going to join the points together that way. So now I'm going to be joining the curve. Okay, I'll start with this, the turning point here. Okay, I have to be careful doing that. Okay, so we have this part. Then next I will join this part. Then we have this part, join this way. Okay, then come this way. Join this turning point first. Okay. Okay. Let's have this part. Drawn this way. Okay. Okay, then we have this part now. Okay. Okay, so we have our point, our curve drawn out this way now, as you can see. So this is a 2-turn helix because it is having 2 complete revolution of the cylinder. So this is 1 complete revolution. So if I have to take the pitch now, the pitch will be from this part here to this part here. So pitch now, if I have to measure this pitch, so this is pitch, so we measure out the pitch. To measure this pitch now, if you look at this, this is giving us 131, that is 13.1, 131 mm. That is the pitch. So if we measure for the other side, it has to be the same thing. Okay, as you can see, this is another pitch. So the pitch of the helix is 131. So this is how to draw a 2-turn helix with the pitch. I hope you find this video helpful. Thank you very much for staying tuned, and thank you for subscribing. Please do subscribe if you haven't done so. See you in my next video. Thank you.